This is Mr. Precella with my Math 1324 class, Math for Business class. And today we're going to be looking at applications of linear systems. We've already worked with some Gauss-Jordan elimination, and hopefully you've been practicing using your calculator to punch those in and to get the solutions, because today we're going to be setting up word problems, and then to get the answers, rather than going through all the manipulation by hand, we'll just punch it into a calculator. And just like in the video, I'll be using a TI-83 calculator, and it might be hard to see it here, but you should watch the video on how to punch these into a graphing calculator once you have the system of equations, if you're not sure how to do that. Okay? So let's just get started. First problem I'm doing here, the U-Drive Rent-A-Truck Company plans to spend $13 million on 320 new vehicles. Each commercial van will cost $25,000, each small truck $50,000, and each large truck $80,000. Past experience shows that they need twice as many vans as small trucks. How many of each type of vehicle should they buy? Well, here we have three unknowns. We need to figure out how many vans, how many small trucks, and how many large trucks they should buy. So we can use three letters. I'm just going to use X, Y, and Z for my unknowns. So X, that'll be the number of vans. Y, the number of small trucks, and Z, the number of large trucks. Now they're going to spend $13 million on these 320 new vehicles. So right off, if X is the number of vans, Y is the number of small trucks, and Z is the number of large trucks, they're going to spend all of the, they're going to buy 320 of those. That sort of gives us our first equation. If we have three variables, you should be expecting three equations so that you have a unique solution. So I'll put this little vertical line here, sort of like an equal sign, because that's giving me my first equation. X plus Y plus Z is 320. Now they're going to spend $13 million, and look at how much each each vehicle costs. That's going to be my cost column right here. Each commercial van will cost $25,000, small truck $50,000, each large truck $80,000. They're going to spend $13 million. That's a 13 with 6 zeros. Now to write an equation for that, if X is the number of vans and each van costs $25,000, then to get the cost of all these vans, you're going to multiply. For instance, if they bought two vans at $25,000 each, you'd say 25,000 times 2, $50,000 to buy two vans. So to get the second equation, 25,000x plus 50,000y plus 80,000z equals 13 million. You know, when we're punching these numbers into the calculator, sometimes you've got to punch in the large numbers, but on this one here, notice we could go through and divide everything by, let's see, this one has 4 zeros, 3 zeros, 6 zeros. If we divided everything by the 1 with 3 zeros, 1,000, then you just sort of mark off. What I'm doing is dividing straight through by 1,000, So here's the equation I'm actually going to write. Oh, I'm actually going to punch into my calculator, just because I don't want to have to be punching in all these zeros. 25x plus 50y plus 80z equals 13 and just 3 zeros. Now there's still something we haven't used. We're looking for a third equation. So here's our first equation. Here's our second equation. The third equation. Well, past experience shows they need twice as many vans as small trucks. They need twice as many vans as small trucks. Twice as many vans as small trucks. This statement here gives students sometimes gives students a lot of trouble, and you've got to think. That's the thing that I think gives the most trouble. You really got to think to get this. They need twice as many vans. That means, what do they need more of? Vans or small trucks? They need more vans. Suppose they bought 100 small trucks. How many vans would they need then? Well, you're thinking 2 times 100, 200. The number of vans, that's x, is equal to 2 times y. That's how you write they need twice as many vans as small trucks. Sometimes students will reverse it. They'll write 2x equals y. No. Think, which one do they need more of? They need more vans. The vans is 2 times the small trucks, not the other way around. They need twice as many vans as small trucks. Well, the way I'm going to actually write that equation, I need the x and y on the same side, so x minus 2y equals 0. I'm going to go ahead and write the matrix that I'm going to use. The first equation, 1, 1, 1, 320. 1, 1, 1, 320. The second equation, 25, 50, 80, 13,000. That third pink equation, 1, negative 2, 0, 0. So there's the matrix. I need to punch into my calculator. And sometimes I'll have students, they want to do it by hand. Okay, but that's not my intention. If I intended for you to do every one of these by hand, I'd have to have assigned a lot fewer problems. Part of this course here is you're learning to do this stuff with some technology to help you out with this manipulation. And that is part of the goal of the course. Let me see. How do I need to position this? Now, I know it's sort of hard to see this, so let me see. That'll help. Okay. So I'm going to go, now this is how I did it with I was using TI-83 Plus in the previous video, and here I'm using just a TI-83. The matrix key is right here. I don't have to hit second. I edit, and it's a 3 by 4, and there's already some numbers in here, but I'm just going to, you know what? Maybe this is not a good way for me to do this one. maybe for the very first one, I'm going to use the second matrix. I'm going to start all over with one new, a 3 by 4 matrix. Again, I had a video that hopefully you've already watched showing how to punch this stuff in. 25, 50, 80. And you see why I divided by 1,000, just so I have fewer of those zeros to punch in there. 1, enter, -2, enter, 0, and 0. So once you've entered all of that, you're ready to quit editing that matrix. And now you're ready to do some math. You want to use RREF, reduced row echelon form. It's almost easier to come right here. Just stand up. Now, matrix. I'm using matrix B. And y'all see that? There's the answer. The final doesn't start till here if you take it away. So, look at that. So, our number of bands, they should be buying 180 bands, 90 small trucks, and 50 large trucks. So 180, 90, and 50. 180, 90, 50. Right? Again, I know the glare's sort of bad. That's why I have that other video where I was trying to show you how to punch this stuff in. Okay? Let's do another one. Matt took clothes to the cleaners 3 times last month. First he bought 4 shirts, 2 pairs of slacks, and paid $16.95. Then the second time he bought 7 shirts, 3 slacks, 2 sports coats, paid $48.88. And the third time he bought 5 shirts, 2 sports coats, and paid $27.93. How much was he charged for each shirt, each pair of slacks, and each sports coat? Well, there's 3 variables again. This was very much like the other one. X, Y, and Z. I think I have room to do it right here. So we want to know how much was he charged for. So this is the cost of each shirt, the cost of each pair of slacks, the cost of each sports coat. So let's see. Oh, wow. Okay, so now the first trip he bought 4 shirts and 1 pair of slacks, and he paid $16.95. On the second trip, seven shirts, 3 slacks, and 2 sports coats. Those are usually more expensive. $48.88. And then the third trip. Notice it's going to give us three nice equations. 5 shirts, 2 sports, wait. 5 shirts, oh, he didn't bring any slacks, did he? Just 2 sports coats and paid $27.93. Well, you know what? Remember, those are zeros there and there. So the equations should be, okay, if you took 4 shirts, then you take the amount that each shirt they're charging times 4, plus the cost of each pair of slacks times 1, you should get $16.95. So 4x plus 1y, no z, is $16.95. 7 shirts times the cost. For instance, if it costs $2 for a shirt, 7 times 2, $14 total for those shirts. Plus 3 times y plus 2 times z gives you 48.88. And then finally, 5x, 5 times the number, the cost per shirt, plus 2 times the cost per coat, is equal to, $27.93. You can almost see the matrix. Do I need to write it out? 4, 1, 0, 16.95, 16 point. And the red would be what? 7, 3, 2, 48.88. And then 5x, no y, 2z, 27.93. Let me get my calculator. Y'all caught up with me? I'm about to get my calculator. The batteries are almost dead. Let me see. Okay. Matrix. I'm going to edit. I'm going to input a new matrix. I'll use the third one there. It's another 3 by 4 matrix. So here go the numbers. 4, 1, 0, 16.95. Then 7, 3, 2, 48.88. 5, 0, 2, 27.93. And once you've entered all those numbers, you quit entering. So you're no longer editing. Now I want to do some math, and either scroll down or scroll up until you get to RREF. That stands for Reduced Row Echelon Form Matrix. Now, which one did I use? That third one? Can y'all see the answers there? So, $2.99, $4.99, and $6.49. So, how much are they charging for each shirt? That was $2.99 for each pair of slacks, $4.99, and for each sports coat, $6.49. Okay. I encourage you to use your calculator. It's worth your time to learn how to do that. Okay. Let's see. How about doing, next one we're going to do this one here. So we're doing problem number 16. The controller or money manager for a number 16. Trying to figure out if I need to. Oh, I guess my batteries will last a little while longer. The controller or money manager for a small company puts some money in a bank account paying 3% per year. He uses some additional money amounting to 1/3 the amount placed in the bank to buy bonds paying 4% per year. With the balance of the funds, he buys an 8% certificate of deposit. The first year, the investment brings a return of $705. The total of the investment is $10,000. So this is just a small company. How much is invested at each rate? So we want to know how much is invested in the bank account, how much is in bonds, and how much is in the certificate of deposit. Once again, 3 unknowns. I'm letting X be the amount in the bank, Y is the amount in bonds, and Z is the amount in the certificate of deposit, which will abbreviate CD. That's fairly standard abbreviation for a certificate of deposit. Let's see now. The bank account pays 3% per year. I'll write that as it's a decimal, 3%.03. So this is the amount of interest. The interest rate. The bonds, how much are they paying? 4%. And that CD, the certificate of deposit, 8%. Now you can almost see a couple of equations at this point. We're told the total amount of interest was $705 that first year. We're also told that the total investment is $10,000. Well, that would be if you added up all of these, so right off, we have two equations. The blue equation would be the amount in the bank plus the amount in bonds plus the amount in the CD is $10,000. Then the second equation, how would you calculate how to get this $705? Well, you'd go the rate times the amount. 0.03 times x plus the rate times the amount plus the rate times the amount equals $705. Now there's one little statement there we haven't used. This statement right here. He uses some money amounting to 1/3 the amount placed in the bonds, in the bank to buy bonds. So in other words, it's saying that the bonds is 1/3 the amount in the bank, isn't it? He uses some additional money amounting to 1/3 the amount placed in the bank. So 1/3 of the bank money is the amount that he's investing in bonds. So Y equals 1/3 X. That's not how we're going to write it. We want the X, Y, and Z's all lined up. Ooh, look at that. Okay. Nothing wrong with your computer there. The light sensor or motion sensor in this room just cut out the lights. And you know what? I think I would rather not have that fraction there. So what I'm going to do, rather than punching in a fraction right here, which your calculator, it should be fine, -1 divided by 3, it'll let you do that. I'm going to just multiply straight through by 3. I just multiply straight through by 3, and this is just my preference for doing this. We would have notice how the 3's would cross cancel. So we'd have a -x plus 3y equals 0. Remember, that's a -1x. And punch this into our calculator. I'll say matrix, edit, matrix. But I'm just putting a new matrix in each time. Okay. 3, enter, 4, enter, 1, enter, 1, enter, 1, enter, 10,000. 0.03, enter, 0.04, enter, 0.08, enter, 705, enter, -1, enter, 3, enter, 0, enter, 0, enter. So I've already punched it in. I've got to quit editing the matrix. I'm going to do some math on it. And that's the RREF matrix 4. So let's see. So can y'all see that? It's 1,500, 500, and 8,000. So X is 1,500. So the amount put in the bank is 1,500. The amount invested in the bonds, it's 1/3 of 1,500. 1/3 of 1,500 would be 500. The amount in the CDs, 8,000. So 1,500 in the bank, 500 in the CDs, and 500 in the bonds, and 8,000 in the CDs. Okay. Any questions there? Let me see. Looking through these. Let's do this one. It's number 18, this example here. A person plans to invest a total of $170,000 in a money market account, a bond fund, an international stock fund, and a domestic stock fund. So there's 4 different funds that she's going to invest in. She wants 60% of her investment to be conservative, money market and bonds. She wants the amount in the stock, in the domestic stocks to be 4 times the amount in the international stocks. She wants the amount in the domestic, Finally, she needs an annual return of $6,800, assuming she gets an annual return of 2.5% on the money market fund. Oh, is this crooked? Let me blow it. 3.5% on the bond fund, 4% on the international stock fund, and 6% on the domestic stock fund. How much should she put into each investment? So we want to know how much she should put in the money market account, how much she should put in the bond fund, the international stock fund, and the domestic stock fund. There are 4 unknowns here. How many equations should we be expecting? Well, the same number. We should be expecting 4 equations. So let's see. I'm going to use 4 variables. And if you want to use X, Y, Z, W, or something, another way you could do it when you have quite a few variables, you could just use subscripts like this. X subscript 1, X2 subscript 2, X subscript 3, X subscript 4. So, or if you want to use A, B, C, D, or X, Y, Z, W, or W, X, Y, Z, whatever 4 letters you want. Now, X1 is the amount invested in the, I'll just go in the order that it's stated here. Okay? The money market fund, the bond fund, international stock, domestic stock. So this is the amount in money market fund. Now you're seeing a truly lazy person. Bond fund, international stock fund, and domestic stock fund. Well, we're told that she wants to invest a total of $170,000. Well, right there, 170,000. Okay. That sort of gives you the first equation. Can y'all see that first equation? It would be add up all of these and you should get 170,000. Again, these are not exponents. These are just subscripts. So one equation, I'll write it like this. X1 plus X2 plus X3 plus X4, 170,000. Continuing on, she wants 60% of her investment to be conservative. Okay? That's money markets and bonds. So this part right here is what I'm going to write as a purple equation. Okay? Maybe I hope y'all can tell that's a purple ink I just underlined that with. She wants 60% of her investment in money market and bonds. Well, the money market fund and the bonds, if we add those together, X1 plus X2, it should be 60% of her total investment. Well, the number that's going to go right here is 60%, so 0.60 times her total investment. I'm just going to punch that into my calculator right now. 0.60 times 170,000. That's $102,000. 102,000. She wants 60% of her investment to be conservative. That means the money market and bonds, those are the conservative funds. Stock funds are usually not considered conservative. So I got that that 102,000 by taking 60% of her total amount of money. Now let's continue reading on. She wants the amount in domestic stocks to be 4 times the amount in international stocks. So I'm going to write that in blue. This is going to be the blue equation. She wants the amount in domestic stocks. So she wants the domestic stocks to be, that would be equal, 4 times the international stocks. So she wants domestic stocks to have more. So the domestic stocks are 4 times the international stocks. You know, that's not how we need it written in order to punch it in. We need all the variables lined up. So I would move this over, and we'd have a negative 4x3 plus x4 equals 0. And we still need another equation. We have 4 unknowns, so we should be expecting 4 equations. She needs an annual return of $6,800, and then here we're given those interest rates. 2.5% in the money market fund, that would be 0.025. 3.5% on the bond fund, 0.035. 4% international, 6% domestic, and the total amount she wants to make is $6,800. Oops. So what would that equation be? Well, you take 2.5% of the money market fund. So 0.025 x1 plus 0.035 x2 plus 0.04 x3 plus 0.06 x4 equals 6,800. Ooh-wee. Now, let's see. I'm going to just try to punch this into my calculator without actually writing out the matrix. Can y'all do that? I think you can. See if y'all can follow what I'm doing here. Oh, so I'll clear this matrix. Let's go ahead and use matrix 1, but be careful, it's not a 3 by 4 anymore. There are how many rows? 1, 2, 3, 4. And how many columns will there be? 1, 2, 3, 4, 5. So this is going to be let's just edit that first. And it's going to be a 4 inner, 5 inner. And notice it's kept some of the numbers there. If you want to clear them out, fine. I'm just going to go straight through. 1 inner, 1 inner, 1 inner, 1 inner. 170,000. Now the next row. 1 inner, 1 inner. There's no x3. There's no x4. 102,000. And the third one, there's no x1, there's no x2, x3 is negative 4, x4 is 1, 0. No, sort of bad calculator, I know. 0.025, enter. 0.035, enter. 0.04, enter. 0.06, enter. And what was that last number? 6,800. Enter. This is one where if you weren't doing it with a calculator, I wouldn't have assigned it. It's not my intention for you to go through and do all of this stuff by hand. So I'm going to say second, quit. I've finished editing the matrix. Now I'm going to do some math on it. I'll just scan up until REF. And I'm going to do matrix. Which one? That was number 1 I used, right? Matrix A. And let's see. 57,800. Oh, let's see. Where do I want to write these answers? Well, you know what? It's going in the order that we defined them in. We defined them in this order right here. Money market, bond, international stock, domestic stock. So 57,800. 44,200. Let's see, what's the next one? 13,600 and 54,400. Okay. That would have been really messy doing it by hand. I wonder if you click on View an Example, how do they go about it? Probably they just set it up and then say, here's the answer. They're not going to actually go through. Or at least I wouldn't think so. I don't know. Maybe they are. Okay. Let's see. We're sort of running out of time, but we have time to do maybe one more. Let's do this one right here. That's number 19. Number 19. Oh, by the way, I wanted to mention, you see, you can scan right and left the way it shows the dots, but all that's not showing are the end of the parentheses, the bracket around the matrix. See how up there it was showing ... If there had been more zeros, then I would have scrolled over, but there weren't. So let's do this one here about the Donaldson Furniture Company. They produce 3 types of rocking chairs. We're doing this one, number 19. The children's model, the stand. Oh, I like this. It's already written. The table's already there. The children's model, the standard, and the executive model. Each chair is made in 3 stages: cutting, construction, and finishing. The time needed for each stage is given in this chart. During a specific week, the company has available a maximum of 179 hours for cutting. So sometimes students put a 179 right here. Well, no, that's a total for the cutting. 111 hours for construction and 90 hours for finishing. Determine how many of each type of chair the company should make to be operating at full capacity. Well, we want to know, ooh, look at that. I was tempted to say X, Y, and Z. And I think that's how I'm going to still keep it. X will be the number of children's chairs. Y is the number of standard chairs, Z the number of executive chairs. We just need to make sure that we're consistent when we punch in our answers here. I'm using an X for children, the number of children's chairs, Y for the number of standard, Z. So it's asking, let's make a note. This is asking for Z first, then standard, and then children. Now, if you want to label this X, Y, and Z like that, that's okay. That's fine. But what would you can almost see the equations right here. You have a cutting equation. It takes 5 hours cutting for every children's chair, 4 hours cutting for every standard chair, 7-hour cutting for every executive chair. They have 179 hours available for cutting. So that equation would be 5x plus 4y plus 7z equals 179. 3 hours construction for every one of the children's chairs, 2-hour construction for every standard chair, 5-hour construction for every executive chair. Those executives need, this is going to be the one that they have to charge the most on, the executive chair. Because they're sure taking the most. Finishing, 2x, 2 hours finishing for every standard, 4 hours finishing for every executive equals 90. Let's see. We have that glare. Matrix. I'll just do a whole new matrix. Oh wait, no, I gotta say edit. And I'm going to use one that I haven't used. Matrix 5. This one will have, ooh wee, look at that. I can't see the equation. There. It's going to have 3 rows, 4 columns. Okay. So here it goes. 5 inner, 4 inner, 7 inner, 179 inner. 3 inner, 2 inner, 5 inner, 111 inner, 2 inner, 2 inner, 4 inner, 90. Now, I've entered all the numbers, so I need to quit editing the matrix, and instead I'm going to do some math on it. I'm going to write it in reduced row echelon form. And that was which matrix? That was this 5th one, E. So here's our answers. X is 10, Y is 13, Z is 11, 10, 13, 11. Let's make sure that we answer the questions in the order they ask. They're asking for the executive, so you punch in 11 there, then the standard, and then the children's. Okay? So these are some nice little application problems here, and hopefully I've done enough for you to get started on them. Okay? This is a big assignment. This homework assignment, there's so much involved here. This is counting as a double assignment, which means it's going to be counting more than your other assignments. Okay? So try to make 100 on it. Okay? So I will, let me see, which one did we not do? Yeah, I have a couple printed out that we haven't done, but we're out of time, and I think I've done enough for you to get started on them, okay? So work on this, and the next time we're going to start some linear programming, okay? So thank you for listening. Bye-bye.